Hey everyone, this is Jenna Jansa here, and in today's episode of Stat is Cool, I'm going to teach you how to do a chi-square goodness of fit test. Now let's get started. Now I know what some of you guys are thinking. Did she just say chai-tea test? Well no, unfortunately chi-square goodness of fit tests are nowhere near as delicious, but still just as cool. So, first we got to remember that chi-square goodness of fit tests are all about proportions. What you're doing is taking a proportion that you've sampled versus a proportion that's supposedly claimed and comparing them against each other to see how far off are they. So, the classic example is M&Ms, where you take the number of flavors in your sample and you compare it against the proportion listed online. But M&Ms are totally old news, so we're gonna go sample Skittles, specifically sour Skittles. First you gotta take your sample, and we're gonna go with the sample of say, this many Skittles. This is about maybe 40 to 50 Skittles, which is a great amount. First we gotta count the Skittles and their flavors. And since I'm way too lazy to do that, we're gonna use hypothetical values. So let's say that there's about 15 red Skittles, and you would divide 15 by 50 to get your proportion. It's that easy. And then you gotta remember that there are 5 flavors of Skittles, and when figuring out your degrees of freedom for a goodness of fit test, you gotta take your number of categories minus 1. So, because there are 5 flavors of Skittles and that's the category, there would be 4 degrees of freedom. And for you guys that aren't very good at comparing degrees of freedom, it's okay, I've got you covered. This is about 4 degrees of freedom in this test, and America has like 200 degrees of freedom. So that's like a lot of freedom versus like a little freedom. Don't worry guys, I'm looking out for you. So, remember when you're using chi-square goodness of fit tests that you've got some really easy hypotheses. You have your null and your alternative, and because you're just working with proportions and seeing how they match up, your null hypothesis is going to be everything is perfect, all the proportions match up, and everything is exactly as claimed. And your alternative hypothesis is everything is not frowny face. Because if one proportion is different, then another proportion could be different, and then another proportion could be different. And that's crazy wrong from what they claimed. So, it's really easy getting your chi-square goodness of fit value, or your chi-square value, because all you gotta do is take your observed counts versus your expected counts and put them into list 1 and list 2 of your calculator. Really simple, really easy. Then you run the test on your calculator and you have your chi-square value and your p-value. But for you guys who want to figure out the value that made the most influence on the chi-square value, you can use this equation. It's your observed values minus your expected values squared over your expected values. And if you wanted to find the total chi-square value by using this equation, you'd just take this equation and you would use it for each individual proportion. So let's say red Skittles, and you'd add it up with all the other proportions, like red Skittles, green Skittles, yellow Skittles, and purple Skittles. And you'd figure out your total value and how far off it was from from 0. So, and then after you've got all that, all you have to do is write your conclusion. You're either gonna reject the null or you're gonna fail to reject the null, as per usual. So thank you guys so much for joining me on another episode of Stat is Cool. Jenna out.